Good morning, CP Pre-Calc. And what we're going to do today is start working on our next conic section of ellipses. All right, guys, so we're going to start talking about ellipses and how to graph them and how to write equations of them. And let's first define what an ellipse is. An ellipse is a set of all points, x and y, set of all points, x, y, in a plane where the sum of whose distance from two distinct fixed points the foci is constant, where the sum of whose distance from two distinct fixed points is constant. And the fixed points are going to be called the foci. They're really a focus, but since there's two of them, the plural is foci. Points, the foci, is constant. And I'm going to explain what that means. And this was moved to a PDF. This kind of got messed up my drawing here. So like what this is here is, I'm going to just add some color. Okay, so right here, we talk about this. The first thing I'm going to talk about is the foci. This is an example of ellipse. What is a foci? A foci here we have two. We have foci 1 and we have foci 2. And these dashed lines shifted. They were supposed to be, you were supposed to have a dashed line here and then a dashed line here. Now, if I label in this first dashed line, this will be distance 1 and this will be distance 2. They're saying the sum of any point. So if I have the point on my ellipse, they're saying the sum of the two distances to the foci, meaning in this case, D1 plus D2. Now, if I picked any other point on that ellipse, I can put a point down here and I can draw a dashed line to that point. This would say be D3 and this would be D4. The sum of those distances would be exactly the same. So if I added up the distance between each foci and the point on the circle, then the sum of the distance is constant. That's what they mean by being constant. All right. So in this case, if I looked at it, they're saying D1 plus D2 would be always equivalent to D3 plus D4, no matter where my X and Y coordinates moved on my ellipse. All right. That's the example of our ellipse. So we will have two foci on every ellipse. Now there's two types of ellipse that we're going to be working with. We have a side to side and we have an up and down. Now, when I say side to side, what does that mean? A side to side just means that it's going to be wider than it is tall. And up and down is going to mean that it's going to be taller than it is wide. That's what we mean by side to side and up and down. So if we take a look at this, let's start with our side to side ellipse. There's something that, well, actually, before we even start that, let's just make a note of something. When I look at this equation, make a note. 0, I'm sorry, I wrote A, and that's written. 0 has to be less than B, which has to be less than A. This means that A is always the largest value. A is always larger than B, and that is key to remember. That is key to remember. So when I look at my side-to-side ellipse, if A is larger than B, I know it's a side-to-side ellipse because A will be under my X value. So you have your equation. It's going to be X minus H quantity squared over A squared plus Y minus K quantity squared over B squared, and that'll equal 1. And in this case, remember, A is the largest number. A is under the X. Therefore, we know it is a side-to-side ellipse. And HK is still going to be my center. Now, if we have an up and down ellipse, okay, we're going to talk about our up and down ellipse next. Your up and down ellipse, you're going to have X minus H squared again, but we're going to have that over B squared. The larger value, the A value, will be under the Y. And that's how we determine if it's up or down or side to side. You want your largest value We'll determine that. So I know it's hard to see my little 2 there. So that is a squared. All right, guys? Now, again, HK is still the center. Now, we're going to label this ellipse. And this is actually an example of just so you know, when we look at this is an example down here of a side to side. And we're going to kind of label some parts. All right, so if we look at this, this is our ellipse, so side to side. Right here, I can identify right here, this is going to be my center. So right there, I have HK, and that will be my center. And we know that's our center. All right, we also know, let's take a look at this. How does A and B and all this help us out here? Now, this is a side to side. In a side to side, the distance between the longer axis, meaning this is going to be the major axis. The major axis is the longer one. So when I say major axis or minor axis, it's going to be, major is going to be the longer axis. In this case, it's going to be a horizontal. When I say in minor, it'll be the shorter one. So the major always works with A and the shorter one always works with B. This would be B from here to here and from here to here. That is B. Okay, guys? So we have A and we have B. Okay? Now, if it was a up and down, A and B would be switched. A would go vertically and B would go horizontally. Okay? Now, if we take a look at this, this will be, we have 2 focus points. So we have 2 foci 1 and foci 2. All right? Now, if I also looked at the points, when I look at my center, if I took a look at what I'm adding and subtracting, this here would always be H plus A, comma, K. This one would be H minus A, comma, K. Up here, this would be H, K plus B. And down here, it would be H, K minus B. Now, whether we add A or B will make a difference based on if it's a vertical or a horizontal major axis. Now, what do I mean by major axis? So if I look at this, if I want to know major axis, it's longer. So this is my major axis. So if I say that, your major axis will equal 2A. Okay, in this case, and if I look at minor, my minor axis will always be 2B. Now, whether it's horizontal, axis is always 2B. So let's think about this. So in this case, in this one, I will have a horizontal. This will have a horizontal major axis. This one, the purple, if I have a side up and down, this will have a vertical major axis. Now, the next thing we need to know is the formula to help us identify our focus points. How do I identify my focus points? Well, make a note. This is important, guys. Let's take a look. All right. What you're going to say, this is important. C squared is equivalent to A squared minus B squared. This is important to help us determine our focus points. Now, if we think about that, for focus 1, in this case, will be H minus C K. Focus 2 will be H plus C K. That C value is what's added and subtracted to our center, whether it's our X or our Y, based on if it's a horizontal or a vertical ellipse. So in this case, I'm subtracting C from H and I'm adding C to H because I have a horizontal ellipse. If I had an up and down ellipse, I would be subtracting and adding C to my K value. So let's make a note of that. All right. So if I make a note down here, guys, make a note. Okay. If in an up and down ellipse, Okay. You would add and subtract C from K. From K. So make a note of that. You would add and subtract C from K. Okay. All right, guys. So here's the information that we're going to use when we are going to try to graph and identify ellipses. So let's flip it over to example 1. Now, I'm just going to go step by step in how I approach this. The first thing I do when I look at an ellipse, and I said, what is the larger value? Is the larger value under my X or under my Y? And in this case, I say, wow, well, I have 25. That's the larger value. That means that has to be my A squared. Now, if A squared is under my X, I know it is an two-side ellipse. If it was under Y, it would be an up and down, but because it's under X, it's a side to side. That means A squared is equivalent to 25. Therefore, A is 5. Now, on the same note, if I look at this, I know, wait a minute, then under Y must be B. So I would know B squared would be 16. Therefore, B is 4. All right. So I'm able to easily identify my A and B values here. Okay. The other thing I'm able to identify is my center, because I have X minus H squared on top and Y minus K squared on top. But since if I look at this and I'm identifying my H and my K, if I take a look at this equation, I have X squared and Y squared and nothing added or subtracted to the X or Y. Then I would know my HK, which is my center, would just be 0, 0. All right. So we can start graphing this. If we're going to need to graph this. So I can start thinking of what my graph would look like. If I do a rough sketch of my graph, I know that I have a center, right? I have that blue center. Let me make it a little bigger at 0, 0. Right there, I have my blue center. That is at 0, 0. So the next thing, so I know I have my X and my Y and I have my center at 0, 0. Now, I know it's a side to side. That means it's going to be wider than it is tall. So when I count over here, when you count over, you're going to be going A horizontally because it's a side to side. Since A is a larger value, that's the one you're going to do horizontally. So I'm going to count 5 in both directions. So if I take a look at that, I'm going to count 5 to the right. So I start at 0, 0, and I go 1, 2, 3, 4, 5. That's where I added 5 to my H value. Then I would do 5 to the left. 1, 2, 3, 4, 5. Okay. So if I looked at those points now, this would be 5, 0. I added 5 to my H value, and this would be negative 5, 0. And remember, what we have here is that center is 0, 0. Now my B value, I would now add to my K because B tells me my minor axis. So I would go up 4. So I'm going to go, B would be 1, 2, 3, 4. I would have let me make it a little bigger. So I have my B right here. And then I'd go down 4, 1, 2, 3, 4. So if I wrote that, I would know that this point now here is H, comma, K plus B, which is 4. And down here would be H, comma, K minus B, which is negative 4 because K was 0. Now this here would be my ellipse. Now, if you take a look at this ellipse, you're able to easily identify the major and the minor axis. So if I look here, highlighted in yellow, the length of my major axis is 10. So we know my major axis is 10. Now I look at the minor. Guys, look at the minor axis. So if we took a look at that, the minor would be 8. Is that good? I hope so. So now the next thing we have to do is look for our focus. Now our focus will always, key thing to note, your focus is always on your major axis. So you know if it's on the horizontal major axis, I have to add it to my X value. So let's take a look at that. So if I take a look at that, I'm adding it to my X value. All right. I have to first identify C though. Remember, you have to find C. C squared equals A squared minus B squared. So I'm saying C squared is equivalent to 25 is A minus 16. Therefore, C squared is 9, and therefore C is not 3. Therefore, that is the value that I'm adding and subtracting to my H to get my foci points. So from the center, I'm going to go 3 to the right, 1, 2, 3, and 3 to the left, 1, 2, 3. It's 3 units from the center. So if I look at that, that means I know I have 2 foci. I have foci 1. The 2 foci, foci 1 and 2. All right. Now let's take a look. We can identify these points. So if I look at this, this would be negative 3, 0. And this point would be 3, 0. So now we identified our 2 foci points. So when you graph this, what you're going to need to do is to determine the center, the foci, the vertices of the ellipse, and sketch the ellipse. What do I mean by vertices? When they ask you for vertices, my vertices of that ellipse are these 4 points. So when they say identify your vertices, it's going to be 1, 2. Actually, let me do them all in a different color. Your vertices, I'm going to do in blue. Vertices would be 1, 0, 4, 0, negative 4, 5, 0, and negative 5, 0. Those are your vertices of your ellipse. All right. So now you have everything that you needed to do to graph this. So now what we're going to do, guys, is we're going to look at example 2. All right. Now, looking at example 2, it's slightly different from example 1 in the sense that our center is not 0, 0, and A is in a different location. How do we identify A? A is always the largest denominator in this case, in our standard form. So in this case, if I look at this, I know that my A is 16. I don't know why it's, okay, there we go. A is 16. So right off the bat, I'm going to say A squared equals 16. Since it is under Y, we know it is an up and down. So the location of A identifies if it's up or down or side to side. So I know this is an up or down ellipse. Now, if A squared is 16, I know A is 4. And if I know A is 4, I can also determine B now. B is under my X. B squared will be 9, so B will be 3. All right. Now, because it's up and down, that means my major axis will be vertical and my minor will be horizontal. So let's take a look. I can also identify my center now. And if I take a look at this, I look at the top. Do I have an H and a K that is different than 0, 0? Absolutely. HK, what am I subtracting from X? 2. Remember, it's the opposite of what you see on the inside because you're looking at what am I subtracting from X? I'm subtracting positive 2 from X. If you have Y plus 4, I have to look at the opposite of 4. What am I subtracting from Y? I'm subtracting a negative 4. So that is my center. All right. So now we have our center, and we can actually now graph not our center and our vertices, because your vertices, A and B, help us determine the vertices. So if I take a look at that, I look at my center. Okay, my center is, let me actually put some dashes in first. All right. So I'm going to graph my center. So if I look at my center, I have 2, negative 4. So 2, 1, 2, 3, 4. So I have 2, negative 4 as my center. Now, because this is vertical, I actually might need to extend this down a little because I have an up and down. All right, there we go. So I just extended it down a little. So let's take a look. Now, because it's up and down, that means I'm going to count my A values vertically. I'm going to go up 4 and down 4. The direction helps us identify where we put our A. So let's do our A first. If I go up 4, I count up 1, 2, 3, 4. And I count down 4. 1, 2, 3, 4. All right, guys? So we went up 4 and we went down 4. Now let's take a look. Those are 2 vertices. And what are the vertices? If I look at that, this one is 2, 0. And down here, this one would be 2, -8. And remember, my center is 2, -4. All right. Now let's look at our B. Our B value, if we take a look at our B value, we have to say is 3. So we're going to count 3 over. 1, 2, 3. 1, 2, 3. That's my B value. So now I have 2 other vertices of my ellipse. So I have, in this case, if I counted 3 over, I have 5, -4. And I have -1, -4. So I can now graph this ellipse. Okay? I can draw the graph of my ellipse to the best I can. I don't expect everyone to be, rock stars, and I know it's hard for me on this to graph it. So I have my ellipse, and you can see now, we now have our center, we have our vertices, we have to get our foci. But if I want to, just to make sure we understand, our major axis, if I look at my major axis is going up and down. So if I asked you for the major axis, the length of my major axis would be, in this case, 8. Then I look at my minor. What's my minor axis? So I look at this and I go across this way. What is the length of my minor axis? My minor axis would be, in this case, what? We went 5, 6. So we can see our major and our minor axis length. All right. Now remember, the foci are always on the major axis. So let's take a look. In order to do the foci, we must first find C. So the formula to find C is C squared is equivalent to A squared minus B squared. So let's take a look at that. That would be C squared equals 16 minus 9. So that means C is going to actually be the square root of 7. Now, we can estimate that, but I want you to give exact points. So if I plug that in my calculator, that would be approximately 2.646. But if I looked at my foci, remember, it's vertical. If it's vertical, you're adding and subtracting the C value from K. So foci 1 should be, the coordinate point for foci 1 should be H, it should be H, K, plus C, and foci 2 should be H, K minus C. And the reason that we're adding and subtracting from K is because it's an up and down ellipse. So if I looked at that and I looked at my center, well, my center H is 2, so 2 and then -4 plus root 7. And the next foci should be 2, -4 minus root 7. Those would be the exact values. So this would be the answer for the 2 foci points. If I wanted to graph them, I would use that 2.646 as that estimation. So I would then say, okay, well, I'm going to go about 2.5 up and 2.5 down, and I can label them. In this case, I added, this would be my foci 1 because I added root 7, and this is foci 2 because I subtracted it. All right. And that's how we would graph and identify our foci. But I want you, and when you're writing the answer to the equation, to identify the points in terms of, right down here, the -4 plus root 7 and -4 minus root 7. All right. So that's how we graph our ellipse and identify its essential points. So what I would like you to do for your assignment today is on the next page, page 3 of 7, you are going to do 1, 2, 3, and 4. Don't forget your quiz is also due by the end of today. I know I left it over for 2 days just in case people had AP exams. If you have any questions, please visit me at office hours. I hope you have a great day, and I will talk to you guys later today or tomorrow. Bye, guys.